Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. I hope you have seen the basic videos of finding the square roots in my previous uploads, and this video is an amazing one. I tell you, numbers up to 999999, 6 nines. You can find the square roots of big 6-digit numbers using the trick which I am going to discuss in this particular video. The video is actually from the chapter number 4 of our ebook of short tricks. This is the title of the chapter: Simplify the squares, the cubes, the square roots and the cube roots. And we are going to learn a special method for square roots of perfect square numbers, which are 6-digit numbers. Long division, right? That's what comes to your mind when you think about such big numbers. But what if I say you don't have to use long division? Or perhaps 10% of long division, 90% smartness. And yes, we can work out the square root of 6-digit numbers smartly. So let's see what is the concept of this particular trick. And before I take up the concept, let me tell you about the ebook of short tricks, which I keep on telling you. This is a must for all the school students and all the college students and everybody preparing for any quantitative aptitude exam. Go for this. This contains 350 smart tricks to simplify the quantitative aptitude exam for you, in which you have huge number of questions to be answered in less amount of time. So smart methods are what you require if you are preparing for SSC, UPSC, CAT, MAT, any Olympiads. This is for you. How do you get it? You can send me a message on WhatsApp 9896369963. This is the WhatsApp number. All these details are available in the description of this video below as well. Right friends, so let's understand the concept of the trick. So I'm not going to take up any question in the concept, but I'll tell you the steps and then we will have the questions in which we will be demonstrating how you can apply these steps to find the square roots easily, right? So we have 6-digit number, right? Say A, B, C, D, E, F. These are the 6 digits. Okay. Now the first thing we have to do is to pair these 6 digits, 1, 2 and 3 pairs. The last pair gives you the unit digit of your answer, and there will always be two possibilities apart from 0 and 5. If it ends in a 0 or 5, then pretty obvious that the answer is also going to end in 0 or 5. But in case the digit is something else here, just like if the digit is 4. Now the last pair of numbers, that is A, B, C, D, E, F, E and 4 suppose, this will tell you that the unit digit of your answer for this square root will be either 2 because 2 square ends in 4, or 8 because 8 square is 64, which again ends in 4. So what is the role of the last pair? It gives you two possible unit digits. That is one thing. The second thing, we will talk about the first pair, AB. Now suppose AB is 32. I am just taking an example, the first two digits being 32. Now this will tell you the first digit of your answer, because 32 is the number which you have to compare with perfect squares, and you have to get to a number which is smaller than 32 but a perfect square, like 5 square. 5 square is 25, very close to 32. You can't take 6 because 6 square is 36, which is above 32. So this 5 will give you the first digit of your answer. Now the very important point is how to get the middle digit of your answer, and then how to check which one of these two answers will be your final answer. For that, I will be taking up a question and then we will practicing it using some more examples. So let's see the first question in hand. Here we have 110224. Now for this, I will be doing the pairing 1102 and 24. Now I told you last pair gives you the unit digit. So my answer will be either ending in 2 because 2 square is 4, or ending in 8 because 8 square is 64, that ends in 4. So the role of this part is done now. What about this part? 11. So for 11, 11 is very close to 3 square. And so this number 3 forms the first digit of your answer. And so the answer either is 3 something 2 or 3 something 8. Now what is the middle digit? That is one of the very important things which you have to understand now. See, here we had 11 and 3 square is just less than 11 and 3 square is 9, right? The difference between 11 and 9 is 2, and then use the middle pair, that is 0, 2. So with the difference of 11 and 9, that is 2, I will suffix the middle number, that is 0, 2. So this becomes 202, and now this 3, what will I do? I will do a bit of long division now. This step is only single step of long division which has to be used in the question. First digit is 3, so I will double 6, right? 3, the double is 6. So I want a single digit so that 6 and this becomes a 2-digit number, and when I multiply it by the same digit, I should get very close to 202, but not above 202. So 63 into 3, you can check. 61 into 1 is 61, very less than 202. 62 into 2, 122, again less than this. 63 into 3 will get me closest to 202, and I don't need to do it further. This 3 which I have chosen here becomes the middle digit of my answer. And now I have two options, 332 or 338. For that I will be using the digit sum method now. If 332 square is this number 110224, then the single digit of this and single digit of this has to be same, right? So let us check. 3 plus 3, 6, 6 plus 2, 8, and 8 square is 64. Now when I add 6 and 4, I get 10, and 10 means 1 plus 0, 1. So single digit of the left hand side, 332 square is 1. For this, 4, 5, 6, 7, 8, 8, 9, 10. So we have 10, and 10 means 1 plus 0, 1. See, we obtained the same single digit on both sides, and therefore 332 becomes the square root of this number. Now if you check the digit sum of 338 square, it will not be 1, and that's where you will eliminate one of the responses which you get through the usual steps. Now just take a while. If you want to replay the video, you can replay it once and feel comfortable with the method, because in the next question I am going to speed up and show you the utility of the steps. So here we have 16, 61 and 20. So 16 means my answer either ends in 4, because 4 square is 16, or I'll have another option 6, because 6 square is 36 which ends in 6. So the job of 16 is done. Now what about 20? 20 is very close to, so I'll write here 20 is greater than 4 square, because 4 square is 16 which is less than 20. So 4 becomes the first digit, and for the middle digit, this is 20 and 4 square is 16. The difference between 20 and 16 is 4, and next pair is 61. So I need to now get close to 461. How? The first digit is 4, so double that, you get 8, and I want to suffix a single digit number with 8. Multiply this 2-digit number by the same digit to get closest to 461, and you will find that 85 into 5 will get me closest to 461. So the 5 becomes the middle digit of my answer. Now either 454 or 456 is the correct answer, and use the digit sum method now. You will find out the exact number out of these two which is the correct number. So let's check 454. 454 square If it is 206116, then digit sum has to be same. Now 5 plus 4, 9, I can actually eliminate 9s. So 4 square, 16. 16 means 1 plus 6, 7. So the digit sum on the left is 7. On the right, 2 plus 6 plus 1 is 9. 9 we can eliminate. 1 plus 6, 7. See? And therefore 454 is the answer for this square root problem. Feeling more comfortable? Let's see two more questions. You will feel that this method actually works for even bigger numbers than 6-digit numbers also. So that is all dependent on your practice. Okay, 42, 51 and 04. 04 means ending in 2, 2 square is 4, ending in 8, 8 square is 64. So one of the job done, this is done. Now 42. 42 is very close to 6 square, that is 36. So 6 becomes the first digit and this is 36. So 42 minus 36 is 6. Now suffix the middle pair 51 with this, so 651. Now the double of first digit 6 is 12. So I need to get close to 651 by suffixing a digit and multiplying it by the same number, and here we get 5 again. 125 into 5 will get me closest to 651, and therefore 5 becomes the middle digit. And now we can check which of these two will get me the final answer. It is 652, because 652 square, when I check the single digit, it will get me 425104 single digit. We can check it. 6 plus 5, 11 plus 2, 13. 13 means 1 plus 3, 4. 4 square is 16. So 7. 1 plus 6, 7. Now here 5 plus 4, you can cancel out the 9. So 4 plus 2 plus 1, 7. And therefore the answer is 652. And the last question here, 75, 86, 41. I think you can work on it. You can pause the video here and try it yourself first. 41. So ending in either 1 or 9, because 1 square is 1 and 9 square is 81. Then first digit it is 75. 75 means 6, 7, 8. 8 square is very close to 75. So 8, 8. Now this is 64. So 75 minus 64 is 11. So with 11 I need to suffix the middle pair 86, and the double of 8 is 16. We need one digit here, multiply them and get closest to the number 1187, and you will find that it is 7. So 7 becomes the middle digit, and now again the digit sum will work and you will get the final answer as 871. See friends, when I showed you the first example, it took so much of time explaining it, but that's what happens, with practice you get smarter. With practice you eliminate the rough work and you are able to do it without consuming too much space and too much of time. That's what mathematics is all about. So friends, if you enjoyed this video, do share it with all your friends who are struggling in such concepts and who want to become smarter with calculations. And do not forget to share it with your WhatsApp groups, that actually helps the educators. Don't forget to subscribe our channel, the amazing channel Suresh Aggarwal's Mathematics Shortcuts, and click the bell shaped icon for getting all the notifications of future useful uploads on the channel. Practice this and let me know whether this method actually works for all 6-digit perfect square numbers or not. All the best.